Section 7.4 Reciprocal Functions. We're going to go over some key ideas. For any function, the reciprocal of the function is 1 over that function. So if our function was x, the reciprocal would be 1 over x. If the function was x plus 2, it would be 1 over x plus 2 would be the reciprocal function. Okay? The reciprocal function is not defined when the denominator is 0. So we really have to look at whenever f of x is equal to 0 because we're going 1 over f of x. For example, if f of x equals x, then 1 over f of x equals 1 over x, and x cannot equal 0 because then we would be dividing by 0, not allowed. Dividing by 0. Use these guidelines when graphing 1 over f of x given the graph. So if I drew a graph, what we're going to do is we're going to make an asymptote, a straight line that the graph approaches but never touches. The general equation of a vertical asymptote is x equals a when a is a non-permissible. So we're going to set f of x to be 0, find out the x's that make that true, and those will be our vertical asymptotes. Okay? As the absolute value of f of x gets very large, the absolute value of the reciprocal function approaches 0. So what I'm saying is 1 over 2, then as the number on the denominator gets bigger, we're getting closer and closer and closer to 0. Okay, 1 over 1,000, 1 over a million, 1 over 55,000 million is very close to 0. So this means that the graph will approach the x-axis but not meet the x-axis. The x-axis defined by the equation y equals 0 is a horizontal asymptote. An invariant point does not change when a transformation is applied. For reciprocal functions, an invariant point occurs when f of x equals 1 and when it equals -1. And why? What's the reciprocal of 1? Just 1. And the reciprocal of -1? It's just -1. So even when you do take the reciprocal, you're left at the same point. To find the x values of the invariant points, we solve the equation f of x equals 1 and f of x equals -1. If a point satisfies the function, then the point x, 1 over y, satisfies the reciprocal function. As the value of x approaches a non-permissible, the absolute value of the reciprocal function gets very large. So let's try an example here. It says sketch the graph of y equals f of x and the reciprocal function y equals 1 over f of x when f of x equals 2x. And I'm going to start with the table of values. So y equals 2x is my first function, and you can't really see it here. In your book you can see it. Y equals 2x and y equals 1 over 2x. Well, when we sub in 4, 2 times -4 is -8, and here we get -1/8. Let's try the next one. We have 2 times -3, which is going to give me -6. The reciprocal of -6 is 1/6. This would be -4, so we'd have -1/4. This would be -2. This would be -1/2. Here we would get -1. The reciprocal of -1 is just -1. This is an invariant point. Okay. -1/4, that would simplify to be -1/2 when we put that in. The reciprocal of that is -2. -1/6, we would get -1/3. The reciprocal of that would be -3. 0 would be 0. 1 over 0 is undefined. 1/6 would be 1/3. And the reciprocal of that would be 3. 1/4 would be 1/2. The reciprocal would be 2. 1/2 would be 1. The reciprocal would be 1. Another invariant. Okay. 2 times 1 is 2. The reciprocal of that is half. 2 times 2 is 4. 3 times 2 is 6. And 4 times 2 is 8. Okay, so we're actually going to graph this. Let's first graph y equals 2 of x. So at -4, we have -8. 5, 6, 7, 8. There's our first point. Okay, our next point, we have, let's do -1 and -2. Let's do a couple more points. We have 0 and 0. We have 3 and 6. So it's pretty clear that we have a line coming up here. So this is the graph of y equals 2x. Okay. Now let's do the graph of y equals 1 over 2x. Okay. So when at -4, we get 1/8. So at -4, we get really, really close right there. Okay. At, let's try at -1, we get -1. And that is right there. We get, sorry, rather at -1/2, we get -1. That's why that didn't make sense. At -1/2, we get -1, and that's that point right there. Notice it's also on the graph. At 1/2, we get 1. Okay. At 1/3, we get 3. 1/3, it goes up to 3. A quarter, it's 4. Sorry, at a quarter, it's 2. Anyways, we can see that this graph starts looking something like this. Over here, the graph is going to look something like that. Okay? Because as these values get closer and closer to 1, the reciprocal of a small number becomes a large number. The reciprocal of this blue stuff. And the reciprocal of a large number gets closer and closer to 0. And the same thing happens on this side. So there we've graphed it. Next it says, state how the functions are related. Okay, so let's look at the domain of this, all the x values. Well, x can be any real number. However, in the green one, x can be any real number except for x cannot be 0. And the reason x cannot be 0 is because that would make this non-permissible. The range, all the y values. Okay, so in the first one, the y could take on any number. In the blue, in the red, y can be any number except for y cannot be 0. There's no way to get a reciprocal to give us 0. The asymptotes, there's no asymptotes here. In this one, it seems like there's an asymptote right here. It seems like we get close to this green line, but we never touch it. And that is a line, and that line is whenever x equals 0. So we have an x equals 0. And we also have a line right here that the red graph never touches, and that is y equals 0. So, and y equals 0, those are my asymptotes. Okay, can x be 0 in the blue line? Yep. Nope. Yes and no. Y can be 0 in the blue. We have that point right here, but not in the red. Okay? What happens to the value of y as x is increased? So in the blue line, as we get more and more x, and my x increases, my y also increases. Okay? But in my red, as I get more and more x, my y is actually slowly getting closer and closer to 0, or it is decreasing towards 0. It's getting as close as it can to 0. Okay? As x decreases in value here, as my x decreases in value in my original graph, my y decreases. However, in my asymptote, it actually increases towards 0. Okay? Couple of invariant points here, things that don't matter which graph you're on. It looks like we have one right there and one right there. And those are both at that's 1 and 1 and -1, and -1. Those are my invariant points. So there's my graph of y equals 2x and y equals 1 over 2x.